Hello, everyone. Today I'm going to talk about the Center for E-Design project. Basically, it's image-guided additive manufacturing. But here we have a new title called Sensor-Based Modeling and Optimization of Additive Manufacturing, because this project has been evolving a lot from its original form to the more advanced form at this moment. My name is Hui Yang, and this is a collaborative project with Dr. Russo from Sims3D. So additive manufacturing brings a lot of benefits. For example, new design freedoms. So we can print complex structures as shown in the right side. And also the manufacture speed is actually extremely fast right now. We can go directly from CAD model and just print the final product. And the materials processing steps are even more streamlined than the traditional subtractive manufacturing process. And additive manufacturing enables mass customization. And those complex structured parts give us expanded function and applications. And because of the life cycle is shorter now, we have reduced life cycle cost as well. However, there are significant challenges in the quality control of additive manufacturing build. So in Sims3D, we had one case study. We used the same CAD model, same machine, but we got different results. And these two figures are shared from my colleagues, Andrew Coward and Dr. Tim Simpson from Sims3D. And from the left side, we see a test part with defective layers. And the right side, the part two, we see the malformed things. Okay, the same CAD model, same machine, very different results. So the defects causing the functionality problems. For example, the Qantas Flight 32, November 4th, 2010, because of the additive manufactured part, oil conduit, and has some internal defect, the whole engine blew off and into the nearby building and causing a lot of damage. But why there's such a huge quality control problems? And now let's have a look at a simple multi-layer AM build quality control challenge. If AM build has 100 layers and the probability for a layer to contain defects is only 1.14%, okay? Then what is the probability for this build to have internal defects? Okay, because so even a layer is about 98, 86%. That's pretty good, but because we have 100 layers, okay, the probability for this build to have internal defects is about 68%. Okay, so if we wanted the build to have internal defects less than 10%, what should be the probability for a layer to have defects? Okay, so based on the calculation, it should goes to 0.11%. That means 0.99%. It has to be defect-free in one layer. So this pushes the quality control into the Six Sigma, as Six Sigma is a well-known term in automotive and semiconductor industry. Now it is not well established for additive manufacturing yet. But how can we push forward the Six Sigma quality management for AM? And this is what we have been studying in the past few years. However, the AM is not like every layer is like independent, as we showed in the previous simple case study. This simple example, we assume each layer is independent, but they are actually dependent. So that's why we propose the sequential decision making. That means layer T-1 is going to impact the next layer and all subsequent layers. And it also depends on the defect state and the defect state we have here, and also which kind of action we take. We are going to have new state. And the new state and new action, we are going to have a new layer as well. So this is like a chain of reactions from layer to layer. So how can we optimize the decision making through all the layers? So this is what we call sequential decision making. But how can we do that? We we can do this because right now we have larger amount of data generated in the process. So go from data to information, to useful information, and then based on the knowledge of each layer, and we're going to have a better understanding of the process, then we sequentially optimize the additive manufacturing. So the idea we proposed is actually called sequential optimization of AM. We have AM, and every time we print a layer, we take an optical image, and based on the image, we estimate the defect. And then based on the probability of the defects, we're going to take different actions, and the actions including you can machine it off this layer, and or you can wait and do nothing, or you can do the laser refusion to the repair. Okay, so different actions, then we go it from layer to layer and to sequentially optimize the AM. Okay, so the details is actually available in the paper. And so in the end, I would like to acknowledge the sponsorship from Lockheed Martin through the Center for E-Design. And without their general support, this work won't be possible. And in the end, this is my contact information. If you're interested in this project, I'm pushing this project forward, especially the Six Sigma quality control for quality management for AM, and make it a reality. And please contact me, and we can talk more and do more through this project. And thank you for watching this video. And this is the end of my talk.